Okay, so now we have this problem here, and we know that the distance from Grayson to Apex, Grayson G to A, is the same as the distance from R to Pine Bluff. Okay, so that's our given. So given, I'm going to go ahead and write it like this. Given is GA. I'm going to actually GA is equals RP. That's our given. And our proof is that GA is equal to AP. Wait, is that right? I'm sorry, I wrote that wrong. So GR is equal to AP. Okay, so how do we do this? Well, we're going to start by writing our T-chart. It's going to be statements and reasons. We're going to write our given here. It's GA is equal to RP. Number one is going to be given. Right? Okay, now what do we do? Well, it's our steps in the proof, right? It's this here. We wrote our T-chart. We wrote statements and reasons. We we numbered our rows. We wrote the given, reasons given. Now we're here on 3. Turn any congruency statements into equations. If you look at this, we don't have any congruency statements. All we have are equations, right? This one right here. So we skip step 3. If midpoint's given, are we given midpoint anywhere in this problem? No, right? If we did, our given here would say, I don't know, A is the midpoint, right? But it does not say that. Third is here. Are we given 3 points on a line? If we are given 3 points on a line, we use seg-add-pos to create an equation from that. And looking at our graph over here, we have not only 3 points on a line, but we have 4 points on a line. So how do we do this? Well, if you're given 3 points on a line like we are here, we create an equation. It's st plus tu equals su. First part plus the second part equals the whole part. Okay? But if we're given 4 points on a line like we are here, we do seg-add-pos on the first 3 points, and to create an equation, namely GA plus AR is equal to GR. Then we do seg-add-pos on the second 3 points to create a second equation, namely AR plus RP equals AP. First part plus the second part equals the whole part. So that's what we're going to do here. Okay. So now I'm going to say GA plus AR is equal to GR. That's my first equation. This one right here. Well, this one right here. Okay. Now I'm looking at my second 3 points, and I'm going to say AR plus RP is equal to AP, and that's going to be seg-add-pos. Segment addition postulate. Right. Okay, and now we are done with step 5, segment addition postulate. So we're going to use substitution to try to get to the proof statement. Okay. So we have 3 equations. We have 1, 2, and 3. So what can I do? Well, I'm going to go ahead and take this GA. Oh, let's see. What do I do? I'm going to take this RP, actually, and I'm going to substitute him in the place of GA. Now, where can I do that? Well, you can't do it in the same equation. Substitution, you don't substitute into the same equation. You substitute into one of the other equations. So, do I see GA anywhere in this equation here? No, I don't. Do I see GA anywhere in this equation? Yes, I do. It is right here. So I'm taking the RP and I'm going to put him right in there. I'm taking this RP and I'm putting him right here for the GA. And my step 3 is going to be RP plus AR is equal to GR. Okay. Now notice here that these 2 expressions are the same. Okay. The order is different, right? They have AR first. This one has AR second, and then they have RP first here, and then they have RP second here. But with addition, the order doesn't matter, right? 5 plus 7 is 12. 7 plus 5 is also 12. With addition, the order doesn't matter, right? So these 2 expressions are the same expression, which is perfect. Because what we can do is anywhere you see this expression, I can put AP, right? And I do see that expression. It's right here. So I'm going to take this AP and I'm going to put him right in there in the place of that expression. Okay. That is substitution. Right? right? Wherever I see the left side, I can put the right side. Anywhere I see the right side, I can put the left side. So anywhere I see AR plus RP, I could put AP. And I do see AR plus RP. It's right here. So I'm going to put AP in the place of it. So step 4 is going to be AP is equal to GR. What is that? That's going to be substitution. And step 3 is also substitution, right? Okay, so now what do I do? Well, look at these two guys. They're almost the same, but this one has the GR on the left side, this one has the GR on the right side, right? I need it to be flipped. GR is equal to AP. That's what I need. And what is the reason for that? Which of these algebraic properties here let you flip the equation? Well, many of you are going to say reflexive, right? But reflexive is same equals same. It's 7 is equal to 7, right? That's what reflexive property lets you say. We're not using reflexive property until chapter 3. So forget about reflexive property. It's symmetric property. Okay? Symmetric property lets you flip the equation around. So I'm coming down here, step 5, and I'm going to say symmetric property. And I am done because now I am at my proof statement.